Good afternoon, ladies and gentlemen. I have a difficult job to do today. It's a last presentation. Everybody is a bit tired, but I will try not to be very boring today. And okay, today difficult and a bit easier because I'm last, and previous speaker very well described all problems which we are having with the gut. And when we are talking about healthy gut, we are talking about digestion and absorption. We are talking about protective barrier. We are talking about gut immunity. And of course, we are talking about balanced gut microbiota. And if you look at this slide, you can see here nice villi. That's what we're waiting for or looking for. But sometimes it's happened like this. And of course, if you have damaged villi, do not expect to have good performance in poultry. Do not expect to have good FCR. That's a major problem, and we should find a way to deal with that. And today, a lot of talks, we're talking about balance, about maintenance of homeostasis in the gut. And I will introduce one more balance, a balance between antioxidants and pro-oxidants in the gut, which we call a Redox Balance. And this Redox Balance, we have on one side of the balances, we have antioxidants. We also have here vitamin E, selenium, carotenoids, flavonoids, and some other nutrients which possess antioxidant activity. We have also in the gut some antioxidants which are synthesized. And if this part of the balances goes down, we are talking about antioxidant system maintenance and good health, including gut health. On the other side of the balances, we have pro-oxidants, like mycotoxins, oxidized fat, iron, copper, some drugs. All of them are meeting in the gut. And if this part of the balances goes down, we'll be talking about antioxidant system disruption and problems with gut health. Now the question is, what are sources of free radicals in the gut? Well, the major source, of course, are mitochondria, which are producing energy, but energy production never been 100% efficiency, so up to 3% of electrons can escape. Electron transport chain produce free radicals. And second major source, of course, are phagocyte cells, those cells which are using free radicals to kill pathogens. And again, there are a few other things like specific enzymes which are producing free radicals in the gut. And this is an example of free radical production in mitochondria. And you can see here, during electrons transport chain, there are at least two sites where reactive oxygen species are produced due to those electrons which are escapes from this electron transport chain. If we look at the phagocyte cell, as I mentioned, for phagocyte, production of free radicals is an essential process. That's a weaponry for them, and they produce this free radical in order to kill pathogens. However, the same free radicals can damage phagocyte itself. Therefore, Redox Balance, antioxidant defenses in the phagocyte cell is a key protection against their own weaponry. Now, what about antioxidants in the gut? Well, first of all, antioxidant enzymes are synthesized there. Selenoproteins are synthesized there. Then heat shock proteins, glutathione and thyrodoxine, ascorbic acid, carnitine, betaine, taurine, all of them are synthesized in the body. And these three, I mentioned already, they are coming from the diet. And today what I would like to do, to spend a little bit more time specifically on selenium and selenoproteins, because selenium, my old love, which I felt 20 years ago with, and today I will share the most recent one, data in relation to the gut health. And before I go to that, I would like to mention once more that an imbalance between production of free radicals and antioxidant defense can cause oxidative stress, and oxidative stress is considered as a major mechanism or major stresses in poultry production. When we're talking about major stresses, we can look at least at 4 different categories of stresses, including environmental stress, technological stresses, nutritional stresses, internal stresses. In general, it's impossible to do poultry production commercially avoiding stresses. Stress is always around, but the major message here is, so independently which stress we are talking about, at the molecular level, at the level of cell, we are talking about oxidative stress. And more than 10 years ago, we published these 2 reviews, Antioxidant Pro-oxidant Balance in the Intestine, Food for Thought. These 2 reviews were related more to human health, but the idea about Redox Balance was there. And recently, in 2015, we published another review, Antioxidant Pro-oxidant Balance in the Intestine, Application for Cheek Placement. And the major conclusion from those reviews is that antioxidant pro-oxidant balance in the gut is a key element in maintenance of gut health. Now, this subject getting a lot of attention from the medical sciences in terms of redox balance in the gut. These are recent reviews, and most emphasis are given to the signaling in the gut, to the balance as a determinant of many functions in the gut, including immune system efficiency, and of course microbiota and the role of microbiota in maintaining this gut, this balance in the gut, receiving more and more attention. Now, when we are talking about antioxidants, we are talking about the whole antioxidant system, where all antioxidants are working together, and every antioxidant has its own job to do. And here, vitamin E I called headquarters of antioxidant defense, carotenoids, communicating services, flavonoids, antioxidant police, vitamin C special forces, and here selenium I call chief executive of antioxidant defense. And hopefully at the end of my presentation, you will understand why I called selenium chief executive. And before we move to selenium, just a few words what we know really about redox balance in the gut, chicken gut, because the most of work on the gut came from medical sciences, from the model system. But in chicken, we published actually 2005 paper on the antioxidant in the chicken gut. We showed here the distribution of vitamin E in different parts of the gut, and you can see here the highest level of vitamin E was found in duodenum and jejunum. Then we look at the fat-soluble antioxidant activity and water-soluble antioxidant activity in various parts of the gut. You see how different they are. And then recently we look at the superoxide dismutase as a major antioxidant enzyme, which actually first level of antioxidant defense. And again, you can see that the highest activity of this antioxidant enzyme was found in duodenum, reasonably high in jejunum, and goes down to colon, it decreasing. But what is interesting, that when we look at the lipid peroxidation, we expected the lowest level of lipid peroxidation in this part of the gut, where the antioxidants are highest, but nothing of the kind. The highest level of peroxidation was found in jejunum, which means we are lacking some information. We need to understand how that antioxidant system, how that redox balance in the gut is regulated, and vitamin E is, to know the distribution of vitamin E alone is not enough. Therefore, let's look at selenium. And selenium, last year we celebrated 200 years of discovery of selenium by Swedish chemist Berzelius. We know that selenium is a part of a range of selenoproteins that play important roles in many physiological functions. And recently, actually, we tried to categorize all selenoproteins. And if you look here, from 25 selenoproteins, which we know exist in poultry, more than half are involved in antioxidant defense, redox balance, and signaling. So it seems likely that most of selenoproteins are involved in these functions. They directly related to gut health. And it could be shown like this. Selenium in the diet, 25 selenoproteins are expressed. They maintain redox balance and signaling, and their major function is protection against oxidative stress. And today, of course, more emphasis will be given to immunity and gut health. And when we're looking at the gut, it's very interesting from the selenium perspective that there are 4 different glutathione peroxidases. The first one was described in 1973. That was the first selenoprotein described. And 20 years later, another selenoprotein, glutathione peroxidase 2, was described. And this is a specific enzyme, selenoprotein, which located in the gut, specifically in the gut, which is having specific function in this part of the body. And here, glutathione peroxidase 2 is mainly expressed in the epithelium lining of the gastrointestinal tract. Glutathione peroxidase 2 knockout highly increases the number of apoptotic cells at crypt bases, and these are indicating that this selenoprotein is specifically involved in maintaining redox balance in the gut, because, for example, apoptosis in many cases is a result of this balance between antioxidants and pro-oxidants. Just recently, we published a couple of reviews on glutathione peroxidase in poultry, because the most of work was done before on mammalian species, and the conclusion from these 2 reviews is still the same, that glutathione peroxidase is one of the most important enzymes of antioxidant defense, and its role, protective role in the gut, it's difficult to overestimate. And if selenium important for the gut health, then selenium deficiency should do something bad. That's exactly what's shown in these 2 last paper, 2016. They showed here that selenium deficiency in chicken actually increased the pro-inflammatory cytokine production in the gut. And secondly, selenium deficiency in chicken increase or activate an F-kappa B specific transcription factor, which is responsive for synthesis of pro-inflammatory cytokines. So in the first paper, 2016, they clearly, at the histological level, showed that there is an inflammation taking place when a low level of selenium was in the diet at 0.003 in comparison to control where was 0.15 ppm selenium. And in the second paper, they did more in detail analysis, and you can see here that an F-kappa B, that's a transcription factor which is responsive for inflammation, and you can see here for 55 days they grow birds, and the level of expression of this transcription factor goes up and up and up, which is 5 times more than in the control level. They also show that the expression of inflammatory cytokines, pro-inflammatory cytokines, are also increased. And then the most recent one, it's 2018 review, which came Selenium and Selenoproteins in Gut Inflammation, a review. So what here they showed? They showed the whole idea how selenium works, and this was in human inflammatory bowel disease. The most of work on this side came from the medical sciences, because there is a specific disease which is related to inflammation. Okay, what they showed here, that actually the microbe which penetrate the barrier can actually activate dendritic cells and macrophages, and then an F-kappa B will be activated, pro-inflammatory cytokines will be synthesized, and inflammation is taking place. And when selenium is used, it can help to deal with that inflammation. Now, let's try to have a look to transfer this model from the human side into the chicken, in the real chicken world. Okay, if we have in chicken, for example, stress, it could be mycotoxins, oxidized fat, dysbiosis, stress at the level of the gut. Then we will have disruption of the barrier function. Then we have a penetration of the bacteria. Again, similar to the previous model, bacteria will activate dendritic cells, and macrophages recognize bacteria. They will increase the activity in F-kappa B. Pro-inflammatory cytokines will be produced. Inflammation is taking place. It's the same as in previous model. Now, in addition to that one, we know that macrophages are also producing reactive oxygen species. In the case of oxidative stress, actually the regulation of production of reactive oxygen species by macrophages can be broken. More free radicals are produced, redox balance disruption, and this will cause apoptosis, this will cause mitochondria dysfunction, and mitochondria dysfunction increase production of free radicals, more free radicals, and situation getting even worse. Now, how selenium can help here? We will finish this with leaky gut. With selenium can actually stimulate production of specific prostaglandin G2 by macrophages, and those prostaglandins are having negative effect or inhibitory effect on NF-kappa B. They also affect transcription factors, and one of them actually involved in prevention of NF-kappa B activation as well. T regulatory cells activate and inflammation goes down. And further, if we look further, selenium is also involved in selenoprotein synthesis, more antioxidant defenses. This transcription factor is responsive for additional synthesis, superoxide dismutase and catalase. And finally, redox balance reestablished. So redox balance reestablished, inflammation down. So what we show here is that potentially this optimal selenium supplementation can help to deal with inflammation in the gut by maintaining under the control inflammation. And redox signaling in the gut, that's very fashionable subject today. And it's actually proven that redox signaling in the gut epithelium regulates self-renewal, proliferation, migration, differentiation. Microbiota contributes to intestinal epithelial homeostasis, and the loss of redox homeostasis is involved in pathogenesis and development of different disorders. And one more paper, very interesting. Microbes are talking to mitochondria in the gut. And mitochondria is a major source of production of free radicals. Therefore, the symbiotic microbiota can keep under the control possible overproduction of free radicals in stress conditions. And finally, this paper came recently claiming that dietary selenium affects both composition of the intestinal microflora and colonization of the gastrointestinal tract, which in turn influence the host selenium status and selenoprotein expression. And generally speaking, our recent review indicates that a form of selenium is very important, how selenium affects gut microbiota. Now, we came probably to the major balance I would like to show you. On the one side of the balance, we have those transcription factors, NF-kappa B and NRF2. NF-kappa B is a transcription factor responsive for inflammation, and NRF2 is responsive for antioxidant defense. A specific transcription factor which actually impose additional synthesis of antioxidant molecules. On the other side of the balances, we have again NRF2, we have beta genes, and we have also NF-kappa B. Now, we have pathogens which actually can can activate NF-kappa B. We have stresses, we have pro-oxidants. I told you about them. Then they increase expression NF-kappa B, and they could decrease NRF2. As a result, we have inflammation, apoptosis, immunosuppression, gut structure damages. Now, on the right side, we have antioxidant protection, we have commensal microflora or microbiota, and we have nutrients which can help, and today I'm talking about selenium as one example. So what they can do, then actually can increase expression in NRF2, increase expression with the genes which are responsive for adaptation, so the animal or chicken can easily adapt to stress, and they can potentially decrease NF-kappa B. As a result, we have maintaining the redox balance, gut structure, immunocompetence, and gut health. And final slide on this subject, NRF2 and NF-kappa B in the body, they are talking to each other, and depending which part of the balances in terms of these transcription factors goes down, we are talking about maintenance of antioxidant defense, which related to gut health as a maintenance of gut health, or alternatively excess of inflammation. And a few more slides just to emphasize that when we are talking about selenium, we need to remember that the action of selenium or efficiency of selenium is very much dependent on the form of selenium, and that sodium selenide, the traditional form of selenium which was introduced in the 1970s, still in premixes, and sodium selenide as a chemical possesses pro-oxidant properties and potentially in the gut can have some damage. And the confirmation, this paper 2010, they used selenide at 0.3 ppm. They made a comparison on histology in duodenum and ileum, comparing without selenium supplementation, and actually they showed the damages done by sodium selenide. And that's my book, which came just recently. And here the organic selenium concept was developed from the previous book, which published 10 years ago. And the chapter here, Antioxidant, Pro-oxidant Balance in the Gut, that's a chapter like 30, 40 pages, which describes this concept I'm talking about today. And one more paper just came this year, Selenium in Poultry Nutrition from Sodium Selenide to Organic Selenium Sources. And here we characterized major sources of selenium in poultry. We call the first generation of selenium supplements the sodium selenide and selenate, which introduced long ago. They are still there, but we need to remember that at the time when sodium selenide was introduced in the diet, we did not know about different forms of selenium. Selenium was considered just as a mineral. So more information accumulated. We know that natural form of selenium in organic one. Organic mainly selenomethionine, and therefore, seleno yeast and pure selenomethionine came to the second generation of seleno supplements, which actually help in solve selenium problems, but they have some problems. For example, seleno yeast, the level of selenomethionine varies first, and secondly, it's comprised for about 60-65%. So what about the rest? The rest of other compounds which have nothing to do with organic selenium. Pure selenomethionine, nice product, but there is a problem of stability. And finally, the third generation, hydroxyselenomethionine, which combine advantages of seleno yeast as a stable product and pure selenomethionine as a concentrated problem. So I came to the end of my presentation, and here I would like to underline once more, redox balance in the gut. That's something which we need to look more specifically, spend more time, spend more money, and that information which accumulated already in medical sciences is enough to prove the point that the regulation of the redox balance in the gut, that's something which can help poultry production. And I thank you very much for your attention.
Yeah, thank you. And we have time for a question. So what is your choice?
What would you recommend as your top 3 antioxidant feed additives in general? Well, I showed you a picture. All antioxidants are important. Remember, there is no one magic bullet which can solve all your problems, right? Because vitamin E, yes, it was discovered in 1922. That's my first antioxidant. I started to work 40 years ago. Okay, it's nice, it's good, but vitamin E alone cannot solve the problem. Vitamin E is necessary. If you look at the level of supplementation today, 100 ppm for breeders, that's the level which are given what the best can be done. In stress conditions like high temperature, maybe higher level of vitamin E needed. But vitamin E doing half the job, because vitamin E reacting with radical, producing hydroperoxide, product still toxic, which must be detoxified, and that's a job for glutathione peroxidase, that's the job for selenium. So selenium and vitamin E working together in tandem. And you cannot replace one by one, but once you have a designed diet, that's good. Flavonoids, that's the most fashionable. There are hundreds and hundreds paper published antioxidants. Sorry, they are not. They are not traditional antioxidants. Yes, they can affect transcription factors. I'm not saying they are not effective. I'm saying to claim they are direct antioxidant, it's wrong. In the feed, they do not possess any antioxidant activity at all. If you look carotenoids, yes, there is some effect of carotenoids on antioxidant system. Therefore, it's for the nutritionist's job to find that optimal combination of antioxidants which can give you best performance.